Have you ever gazed up at the night sky and wondered how stars come into existence? Well, let's delve into this cosmic mystery and unravel the birth of a star. Stars are like the celestial torchbearers of the universe. They are gigantic bodies composed of hot gas that emit light and heat, painting our night sky with their brilliant glow. But where and how does a star begin its life? It all starts in the far reaches of space within dense regions of clouds known as nebulae. These nebulae contain dust, hydrogen, helium, and traces of heavier elements. Over millions of years, the force of gravity pulls this gas and dust together, and a dense, hot core known as a protostar forms. This is the very first step in the life of a star. So a star begins its life journey in a nebula. But how does it evolve from there? Stay tuned as we continue on this cosmic journey. From a simple cloud of dust and gas, how does a star emerge? Well, the magic begins with gravity, this cosmic force that begins to pull the dust and gas together into a central mass. As this mass grows, so too does the gravitational pull, attracting more and more particles from the surrounding cloud. This process, known as accretion, results in an increase in pressure and temperature at the core, birthing what we call a protostar. But the protostar is not a star just yet. It continues to gather more mass from its surroundings, growing hotter and denser. The pressure at its core rises and the temperature soars to millions of degrees. It's at this intense heat and pressure that hydrogen atoms begin to fuse together, creating helium and releasing a tremendous amount of energy. This process is known as nuclear fusion. Once nuclear fusion begins, a star is born, but its journey is far from over. Just like living organisms, stars also have a life cycle, but what does this life cycle look like? Well, it's a journey that's as fascinating as it is diverse, and it varies greatly depending on the star's mass. Consider smaller stars like our very own sun. These celestial beings spend their lives burning through their hydrogen fuel. Over billions of years, this process transforms them into red giants. As the fuel continues to deplete, the star sheds its outer layers, eventually leaving behind a white dwarf. On the other hand, larger stars have a more dramatic fate. When they exhaust their fuel, they don't just fade away. Instead, they go out with a bang in a spectacular supernova explosion. The aftermath of this cosmic event leaves behind a neutron star, or in some cases, a black hole, the densest objects in the universe. So, from birth to death, a star's life cycle is a fascinating journey of transformation. What happens when a star reaches the end of its life cycle? Well, it's akin to the final act of a grand cosmic play. For smaller stars like our own sun, they eventually exhaust their nuclear fuel. The outer layers expand and shed, leaving behind a dense, hot core known as a white dwarf. Over billions of years, this fiery remnant cools and dims, eventually transforming into a black dwarf, a silent sentinel in the cosmos. On the other hand, for larger stars, the ending is more dramatic. Once its fuel is depleted, the core collapses under gravity and rebounds in a supernova explosion. The residue might form a neutron star, which, if it spins and emits beams of radiation, becomes a pulsar. For the most massive stars, they may collapse into a singularity, an area of infinite density, creating a black hole, a region from which nothing, not even light, can escape. So the next time you gaze up at the night sky, remember the incredible journey every star has been through to shine bright for you.